Moving on to another question. We have this inequality that we have to solve, and we have to solve it with a sign chart. So we got negative 9x to the power 4 minus 30x to the power 3 plus 51x squared plus 144x minus 108 has to be greater than or equal to 0. So notice how this inequality is nice because everything is already on one side for us. We don't have to bring stuff over and then simplify it. It's all simplified already. So now what we have to do is we just have to factor this polynomial on the left side. So first thing we do, we check whether we can factor any constants out, any variables out. Can't factor any variables out because this 108 has no variables attached to it. But notice that we can take out a 3 from all of these coefficients. And I would actually suggest taking out a negative 3 so that leading coefficient ends up being positive. So if we factor out a negative 3 from all of this, negative 9x to the power 4 divided by negative 3 gives us 3x to the 4. This would end up being positive 10x cubed minus 17x squared, right? The way I'm getting all these is I'm just taking this value, dividing it by negative 3. Get positive 10x cubed. 51x squared divided by negative 3 gives us negative 17x squared. Notice how the signs are all changing because we factored out a negative number. Right here we would get minus 48x, and this would be negative 108 divided by negative 3 gives us positive 36. We have to find when is that greater than or equal to 0. So now notice how we have to factor this quartic function in the bracket. So the way we do that with Factor Theorem. So we have to plug in a bunch of values. So if we let that whole quartic function be f of x, right? So we have to plug in a bunch of values. So if we plug in f of 1, that will not give us 0. F of negative 1 will not give us 0. If we plug in an x value of 1 and negative 1 for all the x values in the bracket here. But an x value of 2 will give us 0. So we know then that x minus 2 is a factor of this quartic function. So what we would do now is we would take this quartic function, divide it by x minus 2 to break it down. And when you do that long division on the side, you end up getting all of this here. So basically, this quartic function divided by x minus 2, you end up getting this quotient, 3x cubed plus 16x squared plus 15x minus 18. Also notice how we got a remainder of 0. So you may want to try this long division yourself, and then if you're not getting it, just look at this after. Okay, so what we've done so far is we've basically taken this quartic function and broke it down into x minus 2 and then this quotient, 3x cubed plus 16x squared plus 15x minus 18. We have to find when is it greater than or equal to 0. So now what we have to do is we have to further factor this cubic. When you get to a cubic, you always want to check, can you potentially do it by grouping? In this case, we can't, because if we take out an x squared from here, we'll be left with a bracket 3x plus 16. Here we can take out a 3, but we'd be left with a bracket 5x minus 6. And those two brackets aren't the same. So unfortunately, we have to do this with the factor theorem again. So again, we have to take this cubic function now, try a bunch of values, plus or minus 1, plus or minus 2, etc., etc. Now before, we realized that f of 1 did not equal 0, and f of negative 1 did not equal 0. So when you get to this point, you know that these values aren't going to equal 0 either, because if they didn't work for this function, then they're not going to work for this function either. So we can actually just skip those values and then go into trying f of 2, f of negative 2, etc., etc. So if you plug in 2 for this cubic, it's not going to equal 0. If you plug in negative 2, that will not equal 0 either. What if we try f of 3, and then maybe negative 3? Well, 3 won't equal 0 either, but negative 3 will equal 0. Sorry, I meant to write equals 0. So because negative 3 is going to work here, when we plug in negative 3 for x, it'll be 0, then we know that x plus 3 is going to be a factor of this. So we could take this cubic and divide it by x plus 3. And when we do that long division on the side here, we end up getting a quotient of 3x squared plus 7x minus 6. Notice how we got a remainder of 0, which makes sense because x plus 3 has to be a factor. So, continuing on with our main inequality that we're solving, so we got negative 3x minus 2, and now we took this cubic function, broke it down into x plus 3, and then 3x squared plus 7x minus 6. We have to find one, is it greater than or equal to 0? So now all that's left is to factor this quadratic. Right, so two numbers that multiply to negative 18, 3 times negative 6, and add up to 7, well, that would be 9 and negative 2. So what we do is we then decompose that 7x into 9x minus 2x minus 6. From the first two, we can take out a 3x and we'd be left with x plus 3. Then we could take out a minus 2, left with x plus 3. So that means that that factors into x plus 3, 3x minus 2. Right? We factored by grouping. We factored that bracket out. So now what we have is negative 3, x minus 2. Now notice that this quadratic is going to factor into these two, and then we have x plus 3 twice. So it's going to be x plus 3 squared. So we'll put that at the end. So we'll put the 3x minus 2 first. And then we got x plus 3 squared, greater than or equal to 0. All right, so a bit of a process to factor this quartic. First thing you want to do, you want to take out the negative 3. And then you got to do factor theorem twice until you get to this quadratic, and then you could factor the quadratic, and then you end up with this. So this here is the factor form of that quartic function, and now we can go into making our sign chart. So as we mentioned before, when we're making a sign chart, first thing we need is the x-intercepts of that polynomial. And because it's factored, we could figure them out. The x-intercept here is going to be 2. Here it's going to be 2 over 3, and then here it's going to be negative 3. So when we make our sign chart, we start at negative infinity, and then we write out the x-intercepts from lowest to highest. So negative 3, then we got 2 over 3, then we got positive 2, and then we got positive infinity. Then we create columns for each of these. And then the rows are all going to depend on the factors that we have. So first thing we got to write is this negative 3 out. Right? What's the next factor going to be? X minus 2. Next factor will be 3x minus 2. And then the next factor is going to be x plus 3 squared. And whenever you get something like this, x plus 3 squared or x plus 3 to the power 4, basically any factor to the power of an even number, then you know that the signs for this factor are always going to be positive. So we could fill that in. And we could actually fill in this negative 3 as well. The negative 3, that's just a constant. It's always going to be negative, no matter which intervals we are looking at. But what about these other factors here? So x minus 2, what we're going to have to do is for these two factors, we're going to have to plug in a value between negative 3 and negative infinity, so like negative 5. If we plug in negative 5 for x minus 2, we get negative 7, that's a negative number. Plug in negative 5 here, that's a negative number as well. Between 2 over 3 and negative 3, an easy value to work with is 0. Plugging in 0 here, negative number, negative number. For between 2 over 3 and 2, maybe 1 we can plug in for these. So 1 minus 2 is negative. 3 times 1 minus 2 gives us a positive. And then between 2 and infinity, so let's say like positive 3. Plugging in 3 here, positive, positive, right? So now, since we have the signs for all of the factors, let's just label this f of x. This f of x is basically this whole thing right here. We're just going to be multiplying all these. So negative times negative times negative times positive, that gives us negative. Negative times negative times negative times positive gives us negative again. And then negative times negative times positive, that gives us positive. And then negative times positive times positive times positive, that would give us a negative. And then also at those x values of negative 3, 2 over 3, and 2, those are intercepts, right? So the value of the function is going to be 0 at those points as well. Right? So now that we have the sign chart, when is this polynomial greater than or equal to 0? Well, it's greater than or equal to 0 in this interval here, right? So when x is between 2 over 3 and positive 2, and it's inclusive of those endpoints because it's 0 at those endpoints as well. Notice how it's not positive in any other interval, but it equals 0 also at this x value of negative 3. And because they're asking when is it greater than or equal to 0, we have to include that x value of negative 3 as well. Right? If it was just greater than 0, then we wouldn't have to include this, and this would be the only interval. But it would be x is greater than 2 over 3 and less than 2. We wouldn't include that equals in the inequality symbols. But because it's greater than or equal to 0, it's this interval here, inclusive of the endpoints, and this x value of negative 3, because that is an intercept. And at negative 3, it's going to bounce at that intercept, right, because it has an even order, but it still hits that y value of 0. And they're asking when is it greater than or equal to 0, so we do have to include that in the solution. And we can actually take this polynomial and graph it, roughly. And we could see whether these intervals are correct with our graph as well. So first thing is, what is the degree going to be? Well, 1, 2, 4, right? Because when we expand this, it's going to be x squared. So this has a degree of 4. What's the leading coefficient going to be? Negative 3 times 1 times 3 times 1 squared, which would be negative 9. So it has a degree of 4 and a negative leading coefficient. So the end behaviors are going to be like this, right? From quadrant 3 to quadrant 4. What's the y-intercept going to be? Y-intercept is going to be pretty large, actually. If we plug in 0 for all the x's, so negative 3 times negative 2 gives us 6 times negative 2 times 9, right? So we'd end up having, because this would be 3 squared, so we'd end up having 6 times negative 2, which is negative 12, and then negative 12 times 9 gives us negative 108. So that's going to be down here. And then the x-intercepts are negative 3, 2 over 3, and 2. So how's this going to look? Well, it's going to get to this x value of negative 3. It's going to bounce at that point because it's an even order. It's going to go through that y-intercept of negative 108, negative 108 rather. Then it's going to go through 2 over 3, go through 2, and then end off over there. Right? So when is this polynomial function greater than or equal to 0? Well, here, between 2 over 3 and 2, inclusive of those, because that's when it's 0, and at this x value of negative 3. So we can see that graphically this works as well, that solution. So we can be pretty confident at this point with the sign chart, with the graph, that we got the correct answer.